Alright, and we're going to be finishing up the M2L2 Activity 2 home experiment with our final experiment, the pressure bottle. Right, so I've got 1 liter bottle of water right here, a pan to catch the water, because I'm just going to spill, cap for the bottle, and 3 push pins placed in it as so. So I have filled it as instructed, and without putting the cap on, I am going to remove the middle pin. And as you can observe, water is coming out, probably for a similar reason as in the first experiment with the balloon in the bottle, because there's a way for the water to get out. So it is, like the pressure's been building up and now it's coming out this hole as air displaces it through here. Now I'm going to put the cap on, and I'm going to screw it in tightly. And then when I screw it in, it stops. I don't have to theorize it yet, but I'm guessing that it's, as I said, is a very similar reason as with the bottle and the balloon, that now I've sealed off the way for air to get in. There's nothing to displace the water, so the water can't get out. Now I am going to loosen the cap slightly. It starts again. Now, why does loosening the cap make a difference? Well, that's because by loosening it a tiny bit, I still create a way for the air to come in and displace the water that wants to get out. So even a tiny loosening allows the water to flow the way it wants to. Okay, so I am going to replace the middle pin. I don't think... Let's see. Alright, so I'm going to replace the middle pin. I'm not going to refill the bottle necessarily because there's already so much in it. And I'm going to cap it. I'm going to take out the middle pin again. And once again, it's not coming out because of the cap. And I'm going to squeeze. And as I squeeze, water does come out. Well, I'm going to see like how changing the pressure with which I'm squeezing changes. So the harder I squeeze, the more comes out, to the point that I'm going over the pan. I'm going to have to clean that up later. See, woo! Okay. When I stop squeezing, all right, we're going to watch it again and see what happens when I stop squeezing. All right, when I stop squeezing, not only does the water stop once more, but air comes in. You saw those bubbles go from the hole up to the surface. So why do I think this happens? Well, I've been squeezing it and changing the area inside, and that's how water was able to come out, because it was sort of like displacement, because there was just like not the area, the volume inside was changing. Like there was no need for air to come in and replace the water because the volume was just getting smaller, period. But the moment I stopped, not only can the water no longer come out, but the bottle is going to return to its original volume, and the volume of the air plus the water is less than the volume of the bottle. So the matter can't be created or destroyed, so it needs to fulfill that entire volume. So it creates a vacuum, and that sucks in the air back up because the water's down there. The water can't get sucked back in. So in the vacuum that's created, it sucks air in to fill up the entire returned volume. Alright, I'm going to replace the middle pin, and I think might as well refill it. It's getting a bit below the top pin. So I'm going to go do that. I'm back. I've refilled it. And remove all 3 pins and the cap. Alright, so the cap's off. This is definitely going to spill out of the pan, so yeah, it's okay, I can clean it up. So out comes pin number 1. Oh, it's not going that far. Out comes pin number 2, and out comes, if it will let me, Pin number 3. Okay. So they are all out right now. The water is coming out of all of the holes. What's wrong with you now?
Actually,
how does the stream of water...
It's not coming out.
It is coming out.
Oh.
Alright. How does the water differ? Well, as we can see, even though the water level is above this hole, and I've taken the pin out, the water is barely coming out at all of the topmost hole, while it's coming out rather steadily out of the second hole, and out of the third hole, it's coming out with an even faster initial velocity, as you can see by the fact that it goes out farther. Like, I'll turn it so you can see. This arcs down much quicker because the initial horizontal velocity isn't as strong, but this, it's going strong. It doesn't even start to arc. It hits the side of the pan. So there is a clear difference in speed of the water exiting the holes based on the height. Alright. You can see I don't need to make a sketch on the paper because I'm filming this. Watch the bottle for a few minutes. Alright, so we're going to watch it for a while and see how the stream changes as the water level goes down. Well, in the case of hole number 1, the water is already below it, so that's... But as you can see, it's quite clearly getting weaker. Like, this used to be going out this far, and this stream is now only going out this far. And even this one, which was going strong with the strong horizontal velocity, it used to be hitting up here. Now it's actually like arcing down and hitting the water before it hits, rather than hitting the wall. As I've been talking, this has been getting weaker and weaker as we speak. So as the water level goes down, that also has a drastic change in the speed at which the water exits the holes. Alright. Why do I think this happens? Well, I think it's mainly because of the equation pressure equals, gauge pressure, because we're ignoring atmospheric pressure, because that's constant everywhere at sea level. Pressure equals the force of acceleration due to gravity on Earth, g, times the density of the water times the height, or the depth of the water. So the water here has a constant density, as you can see, just want to point out, this, like, it doesn't even have enough initial velocity to come out, like it's dribbling down the side. Anyway, water has a constant density, well, all substances have constant density, but water's density is 1,000 kilograms per meter cubed. I believe that's, yes. So, and also, we're always on Earth, so the acceleration due to gravity on Earth is going to stay constant too. So then that's 9.8 meters per second squared. So acceleration is constant, density is constant. What changes is the depth or height. The second hole was rather far down from the first hole. The third hole was even farther down the bottle. So the depth of the water was greater here. The depth of the water was greater here than here, and even greater here, which is what caused the increased pressure, which is what caused the water to flow out faster. But now, as the water level goes down, depth doesn't mean like from the top of the bottle. Depth is relative to the water. So as the water level goes down, the depth in relation to the water line goes down as well, which is why we see the pressure, and as a result the speed of the water exiting the hole is decreasing. Because this depth that helps determine the pressure is shrinking. And as it shrinks, it's the one factor that isn't constant, so the pressure decreases as well. Alright, I'm going to... That's enough for you. Oh, that's interesting. The pressure has become so low that we haven't passed this hole yet, but there's still just not enough pressure for water to pour out. Nothing's happening. Alright, so I am going to replace each of the 3 pins. I am going to take this over and refill it. I'm going to take the pan and empty it out because I like water not on my kitchen counter. Here we go. Alright, and here we are again with the 3-pinned, filled up liter of water. So, replace all 3, and now the instructions want me to cap it too. So I'm going to tightly cap it, and I'm going to remove any of the 2 pins that I want. So let's go for the bottom. Okay, as you can see, in order to pull it out, I was squeezing a little bit, which is why some came out initially, but nothing's coming out. I'm going to pull this one out. Oh, okay. So, now that I've pulled a second pin out though, water starts coming out of this one. And as you can see, we see air bubbles rising up through this one. So now that we have 2 holes, we have a method for air to come in and displace water as water flows out due to the pressure. So that's why the water is able to pour out now that I've removed 2 pins instead of 1. Right, now it wants me to try 2 other pins. So I'm going to cap this. Once again, it stops. Now I'm going to use U. Once again, we see air coming in here as water pours out there. So, sorry about that. I'm going to pin that in. We'll try it with this one. Ah, okay. It appears... Let me test something. Yes, okay. So, as you can see, I'll turn it so you can see it better. When I have air coming in this hole, it doesn't shoot out as strongly as when I have air coming in this hole. You can see the initial horizontal velocity is much greater when I use this hole rather than this one. Why is that? Because the depth, the relative measurement from the top of the water to the bottom of the